Okay, it's quite simple. I will go rapidly through it. It's just to provide some information about the program, and for those of you who are, I've been working with related contract or related activities, some information about where we are and what are the next steps. So what is new and what is coming up next. So Copernicus Climate Change Service is one of the 6 thematic services that constitute the service component of the Copernicus program. Copernicus is the Earth observation program of the European Commission, and the climate change service is implemented by ECNWF on behalf of the European Commission. As you can see in our website, the mission statement is to provide authoritative information about the past, present, and future climate, as well as tools to enable climate change mitigation and adaptation strategy by policymakers and businesses. And this is quite a mouthful in terms of mission statement, and still there is one important component that is missing, which is this is an operational program. And this has 2 implications. One is that we are not doing research for the sake of it, so the emphasis is not developing the knowledge or the science underneath, but rather to make it useful and tangible for people. And secondly, is that it is not something that we do when we have time. This is something running as much as possible 24/7 with full support, training material, documentation, and so on and so forth. So what is in the climate change service? Well, we provide observation, climate-related record, ECV, so essential climate variable, and climate reanalysis, but also seasonal forecasts in Europe and further afield, climate model simulation, both global and regional, as well as sectoral impact indicators. So quite a rich portfolio in providing the data in a way that is accessible and useful and standardized. So if you browse through our catalog, so the climate data store, you will see that all the entries into the climate data store have the same structure. So they come with an abstract, they come with a documentation, they come with a way of retrieving data, independently whether they are located in our servers in Reading or coming from a server on the other side of the globe, and independently whether they are observation or projections. Furthermore, in a couple of weeks' time, we'll add another tab, which is the evaluation and quality control tab or quality assurance tab, which will provide much more information about the quality attribute of any entry in the data set, including information about validation and the like. So stay tuned if you're interested in that. So the EQC, the evaluation quality control, is really quite rich. So provide a data set overview, but also detailed information about the uncertainty quantification, the scientific methodology, the validation, the intercomparison, and so on and so forth. And this is variable specific. So meaning for each variable, for each data set, there will be a quality brief that you will be able to browse. So in terms of application, this is a big step forward. And as well also represent a very significant undertaking for the whole program. So as I said, stay tuned. But it's not just about the data itself. So we have a private cloud here at ECNWF that is not a high-performing computer, but is a decent cluster, let's say. And this cluster is used to run the catalog that I was mentioned before, but also to provide a computational layer that simplify the use of the data, simplify the transformation of the data into information, into application. And this has been further extended last summer with extra storage and more computational facility to facilitate the user uptake and the user manipulation of the data. So what does it mean in practice? In practice means that there is a computational layer on the cloud that can be used, and there is now enhanced documentation on what you can do with that data and how to manipulate the data. So there are application galleries, there are tutorials, there are how-to guides that guide you step to step on how to transform the data that we have on the stores into plots, into subset, into indicators that you may need or require for your application. And this is part of a broader exercise that we are doing for a number of different sectors, and is really the key part of the sector information system. So this is the part of the program that deals with application. And the idea is to develop application for a number of sectors. So you have a list of sectors here on the left: agriculture, biodiversity, and so on, and energy, and the climate data store. And we want to develop not only applications that are specific to to specific sector, but very much example on how that transformation of data into application can take place. And we want to maintain, as for everything into the climate data store, a very high level of quality. So provide these services as a bit of a benchmark of quality with respect to good practices, with respect to what, which way data can be transformed in information and fed into decision and policies. As Alberto mentioned, this symposium is not the first. We have run a number of activities in the past, both within specific contract and more widely in the context of engaging with broader audiences. So this was the first energy symposium, and we had a second one in Paris, and as you can see, the number of people engaged was farther today. So I'm very pleased by that. And these events are important also because the entire program is user-centric in the sense that we put the user at the center of what we do, collecting your feedback, so to change and evolve the program in a direction that helps you in your activities. So that purpose, and now has some 4,000 requirement to inform the next phase. Also the user profile, so your profile, now almost a fifth of our audience is represented by public and commercial entities. Each one of them represents roughly a fifth of the a very good change in the landscape, and this energy sector that has been one of the most active sector in uptaking our product, and so I look very much forward to maintaining a close relationship with this sector in the future and the next delegation agreement. So just wrapping up and pointing this information to those who are a bit more used to the program and what we do, highlighting what are the new elements that we want to take in the next delegation agreement, so from next year onward. And as you can see, we want to increase the number of ECVs that we are currently providing to probably something around 35 ECVs. Do more in terms of all satellite data to support an extension or an improvement of the extension of the analysis back in time. Add the behavior prediction, so there is element, but this can probably be enhanced in the next phase. It's not set in stone. And in terms of SISs and in terms of application, the message is to link even stronger than it is now with the climate data store and the toolbox. So an example of transformation of the data and the catalog into applications now. And finally, the EQC that we have just launching and will represent an important backbone for the next phase. There is also another news, and is the fact that I changed my role. I'm now the director of the program, and I'm very pleased that we recruited Chiara Cagnazzo as the manager of the sectorial information system, so the person responsible for the application I was referring to. So Chiara will be the main point of contact for the energy activities in the future, and I'm absolutely certain she will do a fantastic job. So there is nothing left to me apart from wishing you a very productive and useful workshop and symposium, and have a good day.
Okay, excellent. Thank you very much, Carlo. And so that was a very good start. And before we go on to the program, I would just like to suggest we go through a poll. So now that we got most people in, there will be people coming in all the time. It's like you know, in a conference room, people come in and out, but that's okay. So we take the opportunity here to have a snapshot of the situation right at this moment by launching the first poll, just a simple demographics essentially of the audience. If we can please all fill out the poll that you will see in a minute, and I'll leave it there for maybe 2 minutes. So there are 3 questions. Okay. You should be able to see the poll now. And the 3 questions. We'll give it 2 minutes. And then we also can show the results live. So we get to know each other a little bit better before we progress with the meeting. Of course, you can see everybody names. Some are more transparent than others, but they're all listed on the panel, participants panel. Still have people coming in. We'll let them in now, and I don't know whether they'll be able to join the poll, but now I'm going through 1 minute. Thanks for people completing the poll. Okay, so got about 50% of the people have voted. If we can get to 70–80%, that would be brilliant. So we'll leave it there for a little bit longer. We're at 60%. Just give it another push. Seem to be stuck around 60%. So let's leave it another 20 seconds. Okay, you're doing a great job. Nearly 70%. Just need 2 more people. Yeah. Okay, so we're stuck there. We're going to end the poll now at basically 70%. Okay, thank you. 70% in, actually. Good, just in. So thank you very much for responding to the poll. So we got the mix here. I'm going to share the results so you can see the mix, a bit more academic specialist, but we have a broad mix. Unfortunately, not many from, or none from private commercial of those that have replied. And level of understanding medium, it's good. And then what you like to get most out of this is climate and energy products, and less so science of climate and commercial climate services. Okay, so we are now ready to go on with the rest of the program. I'm going to close this now and share my screen again, where I've got the agenda and the presentation, and I'm also going to switch on the camera so you can see me. Okay, so the agenda for the rest of the morning is the following. We got a brief overview from myself about the scope of the C3S Energy Operational Service, and then we go through energy indicators, and then the other, particularly for the historical stream, we have 3 streams, as we will see. The second one is seasonal forecast, and third one projection, and fourth with a little bit about the visual demonstrator, and then the question and answer session. So the speakers, you can see there the names. I won't read them out, but probably they are familiar to many of you, and also the organizations there. So I want to first of all thank apart from C3S for the support and funding, the partners that have participated in this round, acknowledging also the previous rounds of proof of concepts, one of which was led by the University of East Anglia, ESAM, and the other one was led by CEA, called C4E, and I'll show you them in a minute. But these are the partners for this project. You will see them also at the bottom of the screen all the way through. So that's the organizations have contributed to this contract or project. The project was run for 2 years, has now completed the first phase, let's say, of preparation of all the data. So it started in April 2018 and May 2018 and completed April 2020. So a couple of weeks ago, but it's continuing on a smaller version, and we'll tell you more about this as we go on. But just a bit about the rationale. So what we wanted to do with this C3S Energy Service, which was going to turn from a proof of concept to operational service, was to ensure that we have all the tools that are useful not only for the climate community, but mainly for the energy community. So it's not just about talking about capacity factors, but also about the energy units, and that required a lot of digging and using the data, the energy data produced by and made available by, for example, NSTOI and other organizations. So we've spent quite a bit of time on that and ensure that what we produce is in line with the data that are provided through those channels. And we've done that through continuous communication through workshops and other channels with the energy sector at different levels. And without going into the complexity of the sector, you may imagine there is quite a broad range of people who work in the energy sector, renewables, non-renewables, and demand and so on. So it's quite a complex area, and obviously we won't be able to address all the aspects, but what we've tried to do to touch on the main aspects, and particularly we've done the electricity component of the energy sector. So when we say energy, most of the time in our project is electricity really, but hopefully you find that useful enough. It's quite broad. And this is the C3S Energy Operational Services in a nutshell. So it shows at the top the 3 streams. So you've got the past that is created through products like reanalysis, so the last 40 years or so, and then the kind of present, which is not really a present, but it's the immediate future produced through the stream 2, which is seasonal forecast, and looking beyond that, over the next several decades, we got the future with the projection stream. And we have, for each stream, climate variables that are turned into indicators, and alongside we have the transformation of these variables into indicators for electricity through electricity demand, wind power production, both onshore, offshore, photovoltaic production, and hydropower, both run-of-river and reservoir. This is, I won't expect you to read this, but just to tell you, the project is, it is about producing data, and it is about producing data in an operational way. And this is just to show you, give you a flavor of the type of complexity that is behind this project. So in the end, people will get the data, but it's also important to understand that there is quite a complex machinery behind all this, and it's full of documentation and data management plan and guidelines and so on to make sure that what is produced is operational, is done on a regular basis, and what is produced is going to follow some guidelines that are not going to change every time you produce some data. So this is very important. We had to spend quite a bit of time setting up all this system, but now it's working in an operational manner. So we'll hear more about all this, so I won't spend more time. I just want to emphasize also some aspects about the engagement, because that's also, as I said, very important to ensure that what we produce is usable and is relevant for people, particularly in the energy sector. And so we've done communication through a number of channels, like we've seen here. I just want to highlight the webinars, for example. You see a list in the next slide. We've also had an advisory board, and we've had a meeting every 6 months, so that's been very useful to keep us on track and get useful feedback on what we're doing, possible variations and changes on future implementation of the service. And we have plenty of documentation as well. We have variable fact sheets, data quality assessment methods and limitations, bias adjustment, user guide for seasonal forecasting, case studies and key messages. and FAQs, tutorial videos to be done. This the last line is something that is work in progress, but there's going to be a lot of material for you, not just the data, it's all the documents, and understand also what we've done, because what we've done is done in a transparent way. So we always say, for example, for every variable we produce, there is a variable fact sheet that is about to say 10 pages where you can find, or maybe less, but there is all the history of the data, where you can find the data, what's been done in terms of processing and all that. So that it's all transparent. There's always obviously limitations about the data we use, because we use only one product for reanalysis, for example. But we try to highlight where there are such limitations, and in any case, it's also understandable that it's not possible to produce multiple data sets. Having said that, ERA 5 is also recognized as probably the best reanalysis currently available, so that's we're in a good position for that. As I said, we had 6 webinars. Here is a list, and you can go back to them and listen to the recordings. They're about an hour each, but we covered all the aspects of the service. So if you would like to know specific aspects, which we won't be able to cover today because we have only 10-15 minutes for presentation, so that's not possible to go the enormous amount of detail that has been produced in the 2 years. So we're going to only listen to some snippets and have a sense of what's been done. We're also developing a visual demonstrator. We had 2 visual demonstrators before, one with the ESM proof of concept and the other C4E, as you can see on the left here. This is being now developed into a tool that is going to be available on the CDS, the Climate Data Store of C3S, and people can then play with that. It's not quite yet available, and we'll hear a bit more about this during the presentations today. In the meantime, you also welcome to use another tool that has been developed under the Copernicus Climate Change Service. And this is the education demonstrator available at the link below. And it contains essentially the same data as ESM, but it's likely going to be developed further using more updated data, and eventually updated also to the rest of the globe. If you want to know more, here are the links. Don't worry about taking too much notes, because this will be available, maybe not immediately, but we'll make this available. Yeah, that's it for my presentation. So thank you very much. As we said, put questions as we move on, and then we'll take them in the question and answer session. I'd just like to hand over now to the next speaker, and that's Sylvie Parey from EDF, Electricité de France, one of the main partners in the contract, the C3S Energy Operational Service. So over to you, Sylvie, and Sylvie is going to talk about the energy indicators. Thank you.
Okay, yeah, thank you, Alberto. So as Alberto said, I'm going to present the results from the energy variables. Do you see my screen here now? Or?
Not yet. I saw it before. Oh, sorry. Yeah.
Yeah,
no.
it's okay.
Yeah. Okay. If you can make it full screen, like slideshow. Yeah.
Yeah. Seem to work. Yeah. Mm-hmm. Slideshow. I'm not able. So I'm sorry.
Okay, that's
yeah. Is it better now, or?
It's not a slideshow, but let's do it this way. I think this, if you can make it bigger, that's good enough.
Sorry. Okay. Hopefully you'll be able to follow the presentation. So good morning, everyone. So my name is Sylvie Parey. I'm working at EDF R&D. And in fact, I'm not in the best position to present this work because I'm not far from being the main contributor, but most of the work has been done by my colleagues, Boutena Weslati and Laurent Dubu, who is now at RTE, and by Yves-Marie Saint-Renan and Lynn Ho from WEMC and Armin. So you're sure you will just have the highlights and not too much details from my side. And so, sorry, I'm going to adjust with the presentation. So as Alberto showed previously, the main goal of C3S-Energy is to assess the effects of climate variability and change on electricity demand and supply. So the models for the C3S-Energy were meant to be flexible and to be easy to use for different types of climate variables, covering the historical observations and the seasonal forecasts and climate projections. And they were meant to be useful at any location in Europe, even if no specific information is available regarding the installed systems or some information about the generation. So we have favored the flexibility of the correlation models against their accuracy. So I will begin with the electricity demand model. The methodology is based on the use of GAM models, which are generalized additive models with temperature, wind speed, and radiation as inputs, as well as the calendar data. Then the first step has been to estimate and remove the trend in electricity demand. And then we used a strategy of calibration validation, cross-validation technique based on the observations to calibrate the models on the period between 2006 and 2014, and then validate them on the last period of observation between 2014 and 2018. And then the calibrated models and validated model were used to reconstruct the data and fit the trend over the whole historical observation period. Here is an example of the results. These are plots made country by country. These are quantile plots, which show how the model reproduces the demand regarding the observed demands for each country. And we can see that depending on the month, the color is for each month of the year. Over the validation period, we can see that for each country, the model reasonably well represents the observed demand. Sometimes it's better than others, but generally the results are quite okay. And if we go now to wind power, we have computed wind power factors for offshore and onshore wind point. But the methodology here is much simpler. We just used simple physical models with two power curves corresponding to two types of wind turbines, one for offshore and one for onshore. And we just put one wind turbine at each grid point, depending on the type of grid points. If it's a land point, which has been defined either a grid point with more than 50% of land, we put here we assume here that there is an onshore wind turbine, and for the ocean points we assume there is an offshore wind turbine, and then we use the power curve to estimate the production. So while doing this, we can't expect that the capacity factors are really really similar to the observed one, because we don't use realistic locations for the wind turbines, but we are confident with the correlation, or the chronology of the capacity factors, and the correlation between the simulated capacity factors and the reference are quite good, as we can see here on the plot. So the quality of the representation depends on the country, but it's reasonably good. And going now to solar power, the choice has been to produce a weighted sum of all the installations, but as we don't know exactly for each country where are the installations and which are their characteristics, Yves-Marie had to estimate a distribution for each country depending on the tilt angle and the module orientation, and then the weighted sum is made on the proportion of the different tilt angle and module orientations. So hopefully, yeah. So the estimation of the weights has been made for using the data for Germany, because here there are lots of data available, and this has been possible to fit a double Gaussian distribution based on the modular orientation and tilt angles. So for each types of countries, such type of distribution can be used, but we have to estimate the optimal tilt angle and define the tilt angle, the main tilt angle, as a proportion of the optimal tilt angle. And using this type of distribution, it's then possible to have a distribution to evaluate a distribution for each different country in Europe, and then derive the capacity factor for the solar power production. So here are the results for different countries. Here again we have quantile plots for different years. Here the colors are for different years, and we can see that here again the representation is fairly good for given by the model compared to the observations we have. It's better for Germany here because we have lots of observations, but for other countries it depends on the quality of the observations and then the quality of the model, but the prediction is quite acceptable. And now the last energy data is hydropower. For hydropower, we had to estimate the reservoir base and the runoff of the river hydropower. And here the methodology used was based on random forests with temperature and rainfall as input variables. And different types of random forests have been tested and compared. And we can see here that depending on the choices made for the model, we had different types of results. So after all these different types, different tests, one model has been selected to be used to estimate the hydropower. production for the different countries. Knowing that here we had a lack of data to calibrate the models, so this had been just calibrated over 3 years of observations, and this would deserve to be better made in the future. So here we have some conclusions about the energy indicators. The objective was to produce a data set of plausible energy indicators. I just remind here that these are not realistic indicators, but plausible indicators in Europe for all energy sources and different climate data sets. The validation confirms that these data are fair enough, but we couldn't go too far with the precision of the reproduction because of the uncertainty in the reference data. And there will be an update of the models to improve the simulations. And the lesson learned from all this work is that there is strong need for data quality control and homogenization within the energy databases to help progress in energy modeling and climate-related studies. So that's all for me. Thank you for your attention.
Okay, thank you very much, Sylvie. And we can move now to the next presentation from the second stream, seasonal forecasting. So Raphael Legrand from Météo France, another key contributor for the service, the climate C3S Energy Service, is going to present the seasonal forecast stream. Please, Raphael, over to you.
Okay, do you have my screen now?
Yes.
Okay, so let's go. So let's switch to the seasonal stream. So thank you, Sylvie, for introducing all these energy indicators, since I'm going to reuse it, since all the computation which have been done for the historical is also done for the seasonal stream. So to introduce what was done for the seasonal forecast, so let's see what have already been on the climate data store on the seasonal scale. So there's already 6 operational systems which are providing real-time operational forecasts. So it's row ensemble forecasts which are already available on the CDS. So you have ECMWF, Météo France, Met Office, NOAA, the American, CMCC, the Italian, and DWD, the German. For this, you also have a quite long list of meteorological parameters. So I think you have almost 30 parameters available. So it's meteorological parameters. And you have some documentation, actually a very technical one. And you have a very good things, the CDS chart, where you could already have some visualization of the seasonal data. Okay, so from this, what have been done in the C3S Energy? So 5 points. The first one is to add another real-time operational chain after this, the seasonal stream. So it's going to provide climate and energy indicators through the CDS for the end users. The climate, so there's already also climate indicators as for row ensemble. The difference is that we are doing some bias adjustment for the key climate indicators for the energy sectors. For the energy indicators, as Sylvie said, we are tackling 4 energy indicators, very useful for the production and supply balance. The fourth point is, of course, the assessment and technical documentation. We really want to provide for the end users the best quality of data and also the best explanation to make it very useful for the users. And finally, for all the level, from the beginners to the very technical, we are providing documentation. It's through the demonstrator, but also through some documentation that Alberto was talking about previously. For the real-time operational service, so each month the operational chain which have been developed during the project make available each month a seasonal forecast for 3 systems, so ECMWF System 5, Météo France System 7, and UKMO System 14. And so it's seasonal forecast from today for the beginning of the month up to 7 months ahead. The time step is 6 hourly or daily. And so as I told you, it's recomputed. We have fresh forecast every 15th of each month. It needs times to compute all the forecast. The field which are made available through the CDS or will be made available very soon on the CDS are a gridded netcdf file for European domain, covering Europe domain. So it's here it's at the bottom right you have a representation of the domain, so covering actually a large part of Europe. And also we are doing some aggregation to give information of a very local area, area aggregated information, and it was done for net zero, so it's a country scale aggregation, but also for offshore wind we are using the Mar Zero. As I told you, actually the seasonal forecasts are by definition ensemble forecasts. So we are dealing with probabilistic forecasts, and as we want to provide the best synthetic data set, we are choosing 4 indicators to provide to the end user. The first one is, of course, the mean anomaly. And after you have 3 probability of going on the lower terciles, comparing to climatology, the medium tercile and the higher terciles. As I told you, we are taking meteorological parameter. It's called here climate indicators. So we are taking temperature, precipitation, solar radiation, and wind. Take all those 4 and doing some bias adjustment to provide really the best data set for the end users. So we are using quantile mapping techniques to do this, and we are taking as a reference ERA 5 distribution. Climatology of the model is sampled through something named the hindcast. So it's 23 years of reforecast. Some details could be found on the documentation. We use some climatic window to be representative of part of the season, a seasonal cycle, and we also have a special process for the extremum values. Something which has to be said also is that we are running this bias adjustment for 1 parameter at a time, 1 location at a time, and also for each forecast horizon and each initialization. So now for the energy indicators, as Sylvie said, there's 4 energy indicators. So for the solar photovoltaic, SPV, wind power production, so we have the onshore wind and offshore wind, hydroelectricity, reservoir and runoff river, and also the electricity demand. All those 4 of the 4 energy model are actually exactly the same as for historical and climate projection. Maybe a very slight differences is for the wind power, since ERA 5 already have 100-meter wind. Here for seasonal forecast, we just have the 10-meter wind. So we have to do a kind of interpolation to 100-meter wind from the 10-meter wind, and this is done from a very simple calculation from ERA 5 data set, and ERA 5 differences between the 100 meters and 10-meter wind. As you see at the bottom of the slide, for each energy parameters, you have a kind of different temporal and spatial resolution. So for SPV, we are at the daily scale, and you have 2 resolutions. So 1 degree resolution to have the gridded data set, but you also have, as I told you at the beginning, the aggregation not zero, so country scale. For the wind power, you have actually a finer time scale, since you are a 6-hourly time step. You also have the 1 degree resolution for the spatial resolution, and not zero and more zero aggregation. For the hydroelectricity and electricity demand, you actually are also on the daily time step, but you only have the net zero aggregation, and you don't have the 1 degree resolution. It's obvious, since actually we need data set to adapt the statistical model, and we only have it at the net zero scale for the moment. I mean, you don't have it at 1 degree resolution. So with all these data sets, so climate indicators and energy indicators, we really want to provide the best quality to the end users. Do not have a bad surprise when the end user is gonna use it, and also want to provide the best documentation to make it very easier for him to use it and handle it. So we are doing some health check of this new data set. It could be some visual check. Since we are developing real-time production of visual plot to see and check if the bias is okay, if you know, if some parameters looks okay. We really want to release a clear and well-commented code. If the end user want to go inside sometimes and see if there is a problem or to understand something, it will do it. And precise and exhaustive information on technical detail. As I told you, we in the documentation, we really give all the technical tips we used to do this bias adjustment, to compute the energy indicators, and so on and so on. For us to go a little bit further on the assessment step, we are choosing 3 assessment score to follow a little bit the quality, the performance score. So there's the bias, the anomaly correlation, and the ROC score. So maybe you really know the bias. It is not enough to follow this first one, because most of the time you are dealing with anomaly for seasonal forecast. But the other thing is, like, when you are looking absolute value, as I told you before, we were actually doing some bias adjustment. So the bias are quite low, but still, if we want to follow if the bias is okay, you could still look at this bias field. For the anomaly correlation, so it's going to give you correlation between anomaly in observation and in forecast. It's a very well-known score for seasonal forecast. And here you have an example of the anomaly correlation for temperature. So I can't be sorry, because it's all the time like this, but for anomaly correlation for seasonal forecast, most of the time maybe a little bit depressing. But you could find some very good information still when you are doing some averages over months. All those kind of tips could be found in the user guide and documentation. And after, you also have a ROC score, but I don't want to spend time to go further with this. Okay, and finally, as I told you, we really want to focus on all the end user, from the beginner to the technical. So we were producing some documentation, technical documentation, frequently asked question on the seasonal question, interrogation, key messages, and there is the 2 webinar on seasonal forecast. So the first one was last summer. It was actually to provide technical details on seasonal stream. And the last one, which was done at the beginning of this month. So it's already registered, but I think it's not online yet. But for this one, it was actually a look back on the 219 and 2020 winter, which was already actually well forecasted. So it's a really good use case to look at this webinar and see, if I was looking to the seasonal forecast of November or October, I could have quite good information for the winter which was coming. So as I told you again, don't hesitate to go through those guidance which were done really for all the level. So let's do a summary of all the data sets which are available through the seasonal stream. So each month, you're going to have a new forecast initiated at the beginning of the month, and you have those all 8 indicators, so 4 climate indicators and 4 energy indicators, and all the temporal and the spatial resolution are recalled here. And let's do maybe an outlook to finish on what could be done after. So we really look forward for the release of the data set on the CDS, since we're going to have the first end user feedbacks and maybe find mistake. I hope not, but definitely look and see if people are using them and they are useful for them. If we go a little bit further in the future, we could think about extending this seasonal stream to the 3 other models available on the CDS, so Italian, German, and the American one, because when you are doing probabilistic forecast, as it is done for the seasonal stream, we definitely want to have as much model as possible. And I think Robert, who's going to come after, will say the same. But we definitely want to have those 6 bunch of model to compare forecast and have a better information on the maybe just reliability in the forecast. And another outlook which could be done is to address the entire globe. For climate indicators, it's obvious and it's just computational problem, I guess. But for energy indicators, it could be a little bit more difficult, since you need data set to fix the statistical model. But especially, for example, for the wind, it could be done quite easily to expand to other locations in the globe. So thank you for your attention. And I just want to say in 2 seconds that it was a great pleasure to work with the seasonal team, which is mentioned here. And that's all, Alberto.
Excellent. Thank you very much, Raphael. That was very informative. Raphael also shown some details about what the indicators are available, and they do vary between stream and stream. So yeah, just bear that in mind. We probably are not going to show the details for all the streams, but if you're interested, there's also Q&A later to ask questions. And we want to now move to the next speaker. So Robert Vautard has been in charge of looking after the projection stream. So thank you, Robert, and Robert was also the project director of the C4E Clean for Energy proof of concept before the C3S Energy, and co-director also of the C3S Energy Operational Service. Thank you, Robert.
Yes, thank you, Alberto. I hope everybody can hear me well and can see my screen as well. Is the thing set up correctly, Alberto, please?
Can you, no, I don't, can you share the screen?
Just 1 second. Sorry, I don't see how to share the screen at the moment.
At the bottom, there is a share screen, green.
Yes,
yeah.
I have done it already, but it doesn't. Can you tell me what you see, Alberto?
Yeah, we
Do
don't
you see any image or something?
Not yet, no.
Not yet. So could you put the presentation on my behalf?
Certainly. Okay.
Please, because I don't see how to get out of this problem.
Okay, so
yeah,
just a second, we'll set it up on our side. Okay. Sorry, everybody, we're getting there. So we got, I just need to share the screen and we are there. Okay, here we go. So over to you. Just tell me when you slide through.
Yeah. So thank you. Maybe we can move to the first one, the next one. Sorry. Yes. So I'm going to talk about climate projections. So you probably have seen already this graph, which is now very famous because it comes from the last IPCC report in 2014. It shows the evolution of global climate and global temperature changes according to scenarios. So these are scenarios that predict the future under certain assumptions of evolution of climate policies and also development. And these are different scenarios for until the end of the century. So now the question is, how does that translate to the energy sector, and why does it matter after all? So maybe next slide. So the climate projections for the energy are important in three respects. First of all, energy users need to predict the climate evolution in terms of statistical distributions, not forecast, for the energy resource and demand, because there is a need to assess the facilities and installations and the production systems. The second point is to assess climate risks in different periods. It's not only the future, but also the present, because the climate has already changed and the observations from the past are, in a sense, already obsolete. So to measure the current risks of certain types of events like heat waves or cold spells or floods, we need to use models. So that's for the future and for the present. And finally, it's good to have, we don't have observations for the future, of course, and to provide scenarios for, say, the evolution of energy mixes, we need to have scenarios and data sets to assess the stability of the systems, for instance. So how do we do that? Next one, please. We use generally, the general approach is to use a global climate model, which is self-contained, which uses, which describes the ocean, describes the atmosphere, describes the cryosphere, the vegetation, and is completely self-contained. So that we observations are input at the beginning of the century, for instance, or last century, and then it's run by itself for several decades or centuries. So this is usually not enough, because the resolution of such global models is relatively modest at the moment, 100 to 300 kilometers, each point distant. While, so that is why we usually use what we call downscaling with a regional climate model, which has a limited area, but higher resolution and the same physics, basically, as the global climate model. And then to go to indices, which could be useful for the energy sector. As Sylvie has shown, we have also models for the energy part. Then we need some impact modeling. So the important thing here is that sometimes we hear a projection could be with one model. We don't think it's a correct way to use these projections, because models have their own, each model has its own assumptions. Not all processes are explicitly resolved. So for instance, clouds in global climate model and even regional climate models are represented, but not explicitly, only the average effect within a cell. So it's very important that we use several models. So at the moment, there is a huge initiative in C3S, which is to provide regional climate simulations for Europe. They are called Eurocordex, and there are about 60 models which provide daily data. So that's a lot of models. So we have to kind of distillate this information, make it, reduce it, and there is about in C3S Energy, we are developing only 10 models, 10 to 15 models depending on the scenarios, but there are 10 models for which 3-hourly simulations are available with 12-kilometer resolution. So that's about the best we can have at the moment, actually. The difference between a GCM and RCM, actually 50-kilometer and 12-kilometer resolution, can be seen here on these maps with precipitation climatologies, where we see that the 12-kilometer model for the island of Corsica, for instance, has a much better location of precipitations on the mountains. So, sorry, there is a need to move to the next one. I'm sorry. So this one was showing indeed Corsica on the left-hand side with low resolution and high resolution on the right-hand side. We can move to the next one. So there's a whole machinery to produce this data and to process this data. Starting from data retrieval, these are enormous files with lots of numbers. And to produce energy indicators, there's a whole machinery that I'm not going to detail. But one is important, maybe next one. Next slide, please. What is important is the biases. Of course, we need to have thresholds in the use of climate models. So we need models not to have biases. So we kind of have to adjust biases. The maps in the bottom show the average bias over the 55 models of Eurocordex for temperature in the historical period. So these biases, these average biases, are not at all large, about half a degree to a degree. But if we look at models individually, we can have biases as large as 5 degrees, negative or positive, depending on the area. So these are the other two maps which are showing the kind of extremes. So it's important to have this in mind. And then we use a statistical technique to bias correct or bias adjust the models. We can also have selection criteria. So this is to be done. And of course, there is in this background the biases of the model. Next one, please. So just to show that these bias-corrected models work, here is a seasonal cycle for average over France, which is the ERA 5 climatology with triangles superimposed with the C3S energy simulations, the average over the 10 simulations for the current climate, for the 2000 climate, and also for the middle of the century. We have the average of the 10 models and plus or minus 2 standard deviation. So what is important to understand here is that not all the models will not all give the same increase in temperature, average over France in particular, and there is a dispersion between the response to climate change. So it's important to take that into account and to not use a single model, or even the average of the models can have some uncertainty. So it's very important. If we look at extremes also, next one, please. So this one shows the temperature as a function of the probability to exceed it in the 2000 or in 2050. 2000 in blue, 2050 in red, and it's the minimal daily temperature over the year for the French average. So we have like extreme days with about -5 on average over the day and over France, -5 or -10. And we see the difference between the current situation and the future, and also the spread of the simulations, which is even larger for extremes. And it's very important to have that in mind, that, for instance, some models in the extremes do not change much the low extremes. The extreme low temperatures are very important for the electricity transmission system. So next one, please. Yeah, so in order to be even more useful, we can reduce the information at the country level or at regional level, and this is available now through the service. So we have this chain of bias correction and then averaging over the countries or regions, and everything is in the form of Excel sheets. So this is all available on the C3S systems. Next one, please. I'll just show some application. I'm not going to show all because I think we are moving with time. So next one, please. So just to show that we can estimate risks. Next one, please. So this graph shows, for instance, we are starting to use this data at the moment. So this one was made with the previous Clean for Energy demonstration, while the previous curves were done with the C3S Energy. So just as an example, for energy practitioners, cold spells, remarkable cold spells can be a landmark kind of events. So they have been witnessed, like the January 63 or January 85, January 2010, February also 2012. So it's very important to have indices which represent this kind of cold spells. And using this data, we can really try to find the evolution of the probabilities or the return period, if you prefer, of such events in the past, current, and future climate, using all the data available. So if we look at, for instance, the January 63 event, which is here characterized as the months of January average, there's an average over France. There was a -1 degree, about -1 degree average in January 63 over the months of January then. And the probability between, in 63 or 85, the probability has changed between 85 and today. It has changed by a factor of 2. So now currently this type of event is twice less probable. And in future climate, typically the coming decades, we have a risk which is also divided by 2 before the middle of the century. So these are the type of analysis that we can do with such data. Here it's France, but it can be done all over the area of Europe, a specific location, whatever. Next one, please. Yeah, so I just want to go quickly, maybe next one, please. That we can do the same exercise for the other types of events like what we call wind droughts. Wind droughts are long periods where wind is lacking, basically, for wind power. And what so these are the same type of curves showing the risk of having very low wind seasons, winter seasons, over Europe as a function of the climate period. So what we see here is also a kind of higher probability of having low wind seasons. So we don't know which one. It may not be the one for the next winter, but it could. The change of probability is estimated here as a factor of 2, and it will continue in the future. Next one, please. And I'm going to essentially conclude by saying that, next one, please. So for the moment, we have 12-kilometer resolution, but what is in our vision for the forthcoming years will be to have what we call convection permitting models, which are typically 2 to 3 kilometer resolution models. And with these types of models in the future, we will be able to solve explicitly the big thunderstorms and the precipitation that are associated with such storms. So I don't want to go into detail and conclude. Next one, please. The ensemble of climate projections can be used in practice for the energy sector, provided the careful model selection, bias adjustment, and other types of treatments also are done. So this is basically what the core service is doing, and providing documentation as well. And they can be used for change in renewable resources, or scenario assessments, or assessment of risks in the current climate and in the future climate as well. Thank you for your attention.
Okay, thank you very much, Robert. And we now go to the last presentation of the session today. So Luc Sanger from WEMC is going to provide a brief presentation around the work that has been done for the visual demonstrator that is being developed. So over to you, Luc. Thank you.
Thanks, Alberto. Let me just share my screen. Can you see that?
Yes, all good. Thank you.
Thanks. Hello, everyone. My name's Luc Sanger, and I'm a data engineer here at WEMC in the UK. And during this presentation, I'll summarize how the final data sets from C3S Energy will be accessible to the end users. So my role in the project has been helping design and maintain the operational system and the 3 data streams. The final part or output of this operational system is the data sets being made available via the Climate Data Store and with an online visual demonstrator tool. So users can interact with and plot the data. The design of the demonstrator is based on the proof of concept tool as part of the ESEM project, and also CLIM4 Energy, which completed, I think, in 2018. And you can see the image there is of the previous ESEM demonstrator, which is still available online to use. So the 3 data streams are produced on a shared virtual machine, which we all on the project have access to and work on. And this is hosted on the ECMWF servers and using open source software wherever possible over the entire project, really. And the outputted data sets from the virtual machine compute area are passed or ingested into the climate data store. Now, it passes some final quality checks and is finally made available via the CDS catalog, and also on a visual demonstrator which will sit alongside the catalog entries. So this is the kind of final stage of the operational system, if you like. So if you're familiar with the Climate Data Store web page, there's an Applications tab, and our demonstrator tool will sit or exist in a suite of applications or tools that are accessible via that tab, and all the applications, including our one, are built using the Climate Data Store toolbox, which is based on a kind of Python framework and interface, so it's all accessible on this kind of ecosystem on the C3S web pages. So this here is the sort of preview of our new tool, and as you can see, the look and feel is close and kept close to the original proof of concept ESEM design, which we looked at on the first slide. So it's based around an interactive map of Europe where you can select countries or sub-regions of countries, and then select variables of each 3 data stream from the project. So there's historical, seasonal forecasts, and climate projections. And these can be plotted, overlaid with different variables and compared, and also overlaid and compared with different countries and sub-regions. And in keeping with the sort of whole open source nature of the project, alongside the application tab, there is a source code tab as well. So any user can go in, look at how the demonstrator has been constructed, and potentially adapt or change the functionality for their own use within the sort of toolbox environment. So it's currently in its sort of beta stages. So the final working version of the visual demonstrator will be available on the Climate Data Store soon. So watch this space. And likewise, prior to that, all the data from the project will be downloadable and accessible via the Climate Data Store catalog. So watch this space, really. And I guess I'd like to just finish this short demonstration as well to say thanks to all the C3S Energy team that we've worked with over the last 2 years, and it's been a real pleasure collaborating with everyone on this project. So thanks very much.
Very good, thank you, Luke. And I cannot but echo also the last words of Luke, and thank all the participants in the contractor project. So it's been a great 2 years, and actually we haven't finished with the presentations of the contract, because we still have some work that has not been shown here in this session, but will be shown in the next session. And these are the case studies. And along with the case studies that have been developed in C3S Energy, we also have several other external speakers, and I'd like to remind you to then come back. We have another half hour now, and then we'll come back after an hour break with another exciting session with a lot of speakers and more Q&A sessions. So before we move to the Q&A now, I would like to run a little experiment that is becoming, I guess, a norm now, given the conditions. And that's basically trying to take a group photo of the attendees. So whoever feels like having their camera on, no pressure, feel free to turn it on. And the only thing with this Zoom, the problem is that we cannot fit all the faces into one screen, so you'll have to bear with me a second. So I've got 3 screens and I need to take 3 screenshots. So once we are ready, I'll leave another few seconds for people to turn it on. Great to see many of you. Thank you for being part of the experiment. Robert, do you want to be part of the experiment as well? Okay, so let's start with the first. So as I said, I need to take 3 because I need to go through the 3 screens. Let's start with the first one. Okay, 3, 2, 1. Let's go. And then the other screen. Okay, got a few. 3, 2, 1, go. And last one. Or maybe there's not. Okay, very good. I think we got most people in. I'll take another one just for good measure, in case I didn't focus well with my camera, because I didn't choose the right focal length and the depth of field. Okay, so here we go. Thank you very much. Feel free to switch it on or keep it on as you wish. So now that we've broken the ice, we've seen each other, feel free to jump in with questions. So let's see on the chat. Does anybody want to just say a word, a question verbally? Feel free to unmute and ask your question. And please state your name, where you're from, and who the question is for. And please keep it succinct. Any volunteer? Don't be shy. Okay,
Hello?
so everything, yes, yeah. Please come in.
Hi, yeah, I can hear you. Good morning, Mr. Alberto. I'm Zadon from Getaco. I have a question to EDF lady. I think her name is
Sylvie, yes?
Yeah, Sylvie. I think her work is transferring the climate data into the energy data and especially the forecastings. Could you please give us a more, maybe I missed, but if it's possible for us to understand how the climate data or indicators considered in the energy model, the equation, that will be fantastic. Thank you very much.
Well, so it depends on the energy models. So the climate data are the inputs for the models. And each model deals with the main data for the energy variable which is produced. So for example, for the demand, we have to deal with lots of variables. The main climate data is a temperature, but we have to deal with wind speed too, radiation in a second step, and this is made with generalized additive models. So, but all the models will be available in the climate data store. So you will have the codes used to derive the climate, the ED energy variables. Yeah, does it answer your question, or do you?
Okay, thank you. So it's indicators like temperature, It's C3.
It's for wind power. It's wind speed at 100 meters. For solar power, it's radiation and temperature, and for hydropower, it's rainfall and temperature.
Okay, perfect. Thank you very much.
Okay, thank you. So, other questions? In the meantime, let me know that let me tell also that we have, as I said, terminated the first major project, part of the project, but the activity is going to continue for another year and 2 months to basically maintain the operational service, which will allow people to access the system on the CDS on a regular basis with, like we heard from the seasonal forecast presentation from Raphael. This will be available every month, as well as the climate and energy indicators for historical. They'll be updated every month. So, and projections are updated once a year, roughly, because they're not regularly updated as models. So that's why we don't need them so often. So please raise your hand or state your question.
Hello, may I ask a question?
Yes, please.
Okay.
Please.
Okay. First of all, I'm Sylvie. I like to thank you all speaker. It was very nice to hear from you. And my question is related. I am a researcher, scientist, academia in the university. My question related with these open source data sets, which I have been using your data sets. I mean, especially not you, but ACMWF data sets I have been using with my students as well in my research. Thank you very much, all of you. And my question is related with the data type. I mean, the data type, GRIP or net-CTF data type, you have been producing these type data sets. However, as you knew that these data sets, we can open and use them with the different operating system. I mean, the Office or Linux operating system. Some countries, in my country, for example, in my university, we have been using Office mostly operating system, which means there is some difficulties related with using this data in different operating system, such as Office system. Is there any way? I know that also you are advising different sources, tools. I mean tools such as open this type data, but there is a lot of question related with these tools, which I have to teach my students and use them. So is there any, I mean, how we can get respond related with the easily open read study these data sets, net-CDF and GRIP data sets. Could you give us some advice related with your data sets type?
Sorry, I was muted. So thank you for the question. Probably, I would say, Luke, would you like to try to give an answer, and then I can also, and other people can try to.
Hi there. Yeah, so the question was about the data formats, and yeah, so
and different platforms as well, using Windows. We had experience using Windows as well. Yeah,
that's right. Yeah, so I mean, any operating system with web access should be able to use the climate data store. In terms of the actual data sets, yes, the NetCDF and GRIB formats, which are the kind of general format used on the climate data store, do need specific tools to open, which are available on Linux and OS X and Windows. But for C3S Energy, we've produced CSV files mainly for that reason. So it's accessible for everyone to use. So actually for this project, you should be able to get the data as CSV files, which will open in Office. I think you were saying you were using. So like Excel, for example, can easily open a CSV file and create some basic plots and things. So yeah, we have tried to make the data as sort of universally accessible as possible, really. Hope that answers your question.
Thank you. Thank you. Thank you very much.
Okay.
Yeah, just to add to that, need to also clarify that some data are still NetCDF files, because the gridded data, when you have regular domains, it's better handled by NetCDF. But as Luke said, you can have tools, for example, the Panoply developed by NASA. You can easily install and view the data and also look inside. But most of the data, our effort was also to, as Luke said, to produce the CSV files, because most people in the energy industry will also require something that is simpler to use, and mostly with spreadsheets. And that's why we produce all these CSV files. But they are mainly for country averages. So we heard about NAT0 and NAT2, which is kind of region provinces in each European country, and eventually beyond that. So
Alberto, if I may.
Sorry.
Yeah, yeah. So Robert and then Chiara,
Yeah.
please. Yeah.
Yeah, just to add on NetCDF, I strongly recommend a very easy to use library and well documented, which is called CDO, which was developed by German teams from DKRZ, I think. Yeah, and this is really easy to manipulate files.
Yeah, but you still need to have I guess, an operating system like Linux or Unix. Is less? I don't know how it works on Windows. Does it work?
I think it works on Windows. I need to check, but
okay.
Yeah.
Chiara, please.
Yeah, just to add a final comment to that. Yeah, of course, there exist several libraries to deal with NetCDF file, but referring at the CDS, I would like to mention that there is the toolbox, that is a software that permits to handle CDS data, and you may operate easily with NetCDF data into the toolbox. So today, the toolbox is also going to be extended to operate with the CSV data that Alberto was mentioning before.
Okay, very good. Thank you, Chiara. So we're being asked, maybe Chiara, another one for you. I mean, we can also answer, but what does soon mean for the demonstrator tool? Weeks, months, years?
Yeah. Thanks for the question. It should be weeks.
Okay.
Optimistic.
We heard it here.
It's registered, it's recorded.
Yes, yes, that's right. Okay, other questions? Otherwise, this may be a good time also to introduce our second poll of this session. Sorry, this is the last one for this session, don't worry. And it's got 4 questions, so we'll leave, they're not complicated, but it may take a little while. So we're going to give, let's say, 3 minutes for everybody to complete. So I'm going to launch the poll, people can also still type questions meanwhile, in the meantime. Okay, so let's go for this. I hope can keep. All right, so you should be able to see now the second poll. After you've seen some of the results, the questions should be clear enough. Maybe some questions are still unanswered, and it could be an opportunity for you to ask questions also related to the questions on the poll. If you don't understand what they mean, then we can clarify, because it's part of the service. So if we have 5% at the moment, if we're able to reach the 70% that we reached before, that would be fantastic. It's going up, good. Going up quickly, over 30 now, and increasing. Let's see, around about another minute on this. Getting to 50%. Just another 20%. Yeah, we can make it. Okay, so I hope the questions are clear. I don't see any questions on the chat regarding the questions on the poll. So hopefully the questions are clear enough. I don't know if there's any questions on if can be alerted. I haven't been able to check on the Twitter, so remember also you can type questions on Twitter or just send comments there, whichever you want to communicate, using the hashtag C3S_energy. Okay, we're nearly at 70%. If 2 or 3 more people can enter the poll, we get to 70 and we're all happy. Yeah, we're stuck at 66%, which is technically 70%, so we could close it. Okay, so we're going to close it at 66%. Thank you very much for your input to the poll. And I'm going to share the results like before. So let's take a look. So which of these do you think would be most beneficial to your work? All of the above. So that's the highest question. That's brilliant. Thank you. And second question, how would you rate the quality of energy and climate information shared with you during the overview session? It looks very good. Thank you very much. 55%. Top question, top answer. And what would you like to see developed in future versions of the C3S Energy Operational System? So here we got a bit of all the questions, but the top one by a small margin is all of the above. So for Chiara to take note, a lot of things to develop here. If people want to perhaps express some particular area now verbally on the chat, please do so. And the last one, which of the 3 streams is the most interesting for your work? So seasonal, or all of the above, seasonal individually, but all of the above. So that's brilliant. Great. And thanks God, there's 0 and none of the above. also in the previous one. So that's great. Let's close this. And so, Chiara, do you want to ask your question, or shall I read it out? I would also.
Yes, I mean, maybe this is more than for the second part, but I would be interested in understanding within this community how interesting may be to explore also another timescale, such as this decadal timescale between the interannual timescale and the longer term projection timescale that was presented by Robert. I don't know if this will be an outcome also of this meeting. Of course, in case there is any scale, but that's maybe tricky. Or maybe you have already an answer to that, Alberto, after your experience with users. I don't know.
Well, by my based on what I hear, yes, there is in principle an interest, but there's also an understanding that it's still work in progress in terms of developing the science, and it's the sciences and the results are not quite ready, I guess, to be used in a kind of operational way, but maybe not in the too distant future. In the meantime, people know that some people already use the projections that Robert displayed to bridge the gap between the seasonal, so a few months ahead, and decades ahead, because that information is also available in the projections. Not at the same level as what would be the decadal, but in the meantime, I think it can be useful to fill the gap. Any other comments, questions? As we're getting close to the end of this first 2-hour session, if there are no more questions, we may terminate it. I see there is a hand here. Lena, you'd like to ask a question? Would you like to say it verbally?
Yeah, I think it's hi. Thank you very much for the presentations. I think it'll be easier to say it. So I'm just wondering if there's going to be a section or a factoid, something that would be accessible for the stakeholders or the policymakers, where they can go and take their information from, just under the data, to explain it to them. Because this is for us people who deal with this, academics, wherever our realm is. And I think we just get used to the lingo and we can do it. However, if there's a possibility, and I understand this could be imposing more work, but if it's a factoid, something simple and easy for policymakers, stakeholders to go to and look at this data. So it actually, in a way, it will support our notion when we are trying to convince them with the quality of the data and influence their decision making. I'm just saying this as a, if that's a possibility, or have somebody thought about this or not. Other than that, thank you very much. Appreciate it.
Yeah, thank you, Lena. And sorry, Lena, where do you work? Just out of curiosity.
I'm an academic. I'm affiliated with Cornell University, and I'm in a family leave of this for the current situation at the moment.
Yeah, brilliant. Okay, yeah, thank you for the question. So yes, short answer is yes, we are thinking about that, but for the longer answer, I would like to maybe ask, without putting anybody on the spot, Claire, would you be happy to respond to this? Claire Goodes from UEA has been involved also in the previous proof of concept, and she's got a huge amount of experience in this area. So, and she's been contributing also to the documentation in C3S Energy. So it's good to hear from Claire.
Okay, thanks, Alberto. I think Alberto in his presentation showed a list of the types of documentation and user guidance that we're preparing. Some of it is ready to share. via the CDS and through the visual demonstrator. So this ranges from the more technical documents like the variable fact sheets, but also includes documents of varying lengths that are aimed at, I would say, more technical users or people who are new to using climate and energy data in this way. One set of documents, what we call key messages. So originally these were developed in the ESEM project, and these are just two pages laid out in a fairly sort of simple way, summarizing, for example, some of the major changes in energy and climate variables. So we've only produced a couple of new ones so far for C3S Energy, but we will be working on more will be produced. Raphael mentioned the user guide for seasonal forecasts. We sort of recognise that seasonal forecasts are quite new for many people. So we produced a user guide that sort of complements some of the information that's available anyway from ECMWF. And then there's the other things like blogs and webinars that aim at different people. And I mean, Alberto can maybe say a bit more about the plans for the next year.
Okay, thank you very much, Claire. And yes, I mean, yeah, we'll continue to provide that information. And if you have suggestions, however, we'd be happy to take it and obviously act on it if we, with the effort we can have on the next phase. Is rather small, but yeah, we'll be happy to consider it, of course. I mean, it's important that this data is used widely. So it's not just for academics, it's mainly for practitioners and policymakers and so on. So that's a lot of the work we've done through the workshops and consultations that also at that level. And we do have, you know, through C3S, there are connections and interactions with the other areas of the EU and STOI and other organizing bodies at the EU level. I don't know if other people want to add as well from the team. Otherwise, I see also another hand from Ayesatu Nidiade. Is it for a question? Ayesatu, would you like to ask a question? I see your hand up.
Yeah, hello. This is Ayesatu from Waska.
Oh, hello. Hi. Please.
I want to ask a question on climate projection for demand over developing region. How do you think that distribution will be well representative over regional countries, probably of West Africa, in terms of prediction of climate distribution in energy demand?
Laurent, is it something you would like to answer?
Yeah, I'm not sure I got the question correctly because the line was not very good, but yeah, basically what we have done for Europe could be replicated for any country all over the world. The only constraint we have is that, and it's a strong one, is that we need good quality data to set up the models, train them, and then to validate them. But as far as you have, let's say, 5 years of daily data for energy demand, then we can imagine setting up a model for almost any place in the world.
Okay.
All right, thank you.
Excellent, thank you. And I forgot to introduce Laurent, actually. Sorry, Laurent Debut at RTE is the transmission operator in France. And before that, he was at DDF, where he played a key role in the C3S Energy. And before that, ESM. So he knows a huge amount of on climate services. So next, we also have a question from Rafa Sanchez from Endesa Enel in Spain, and Rafa has been very helpful on the advisory board for C3S Energy. Thank you. Rafa, over to you.
Hi, Alberto, and congratulations for all the members that make a very interesting exposition. My question is about the situation after COVID. The COVID situation changed the aspect of our cities. The long-term exposure to air pollution is a key element to understand for future. Regarding the transport, the heating, and the rest of PM 2.5 particulate matters. Are you considering introduce some information about pollutants on the city, because the pollutants make a key element to transition toward the more renewables and more electrical mixing in our cities? That's the question for me.
Yeah, thank you, Rafa. Yeah, it's certainly an important question, and it's something that we've been observing in the past few months. Personally, with WEMC, we've done a few blogs on this and data analysis, taking data from CAMS. So we are under the Climate Change Service program. There is a parallel program, CAMS, so for atmospheric monitoring, and that produces all these indicators, like you said, the particulate and nitrogen dioxide and carbon monoxide and so on. And those clearly show, an impact from COVID in terms of air quality and factors related to industrial production and so on, and traffic and all these things. So personally, yeah, I think it would be important also to demonstrate, what's happening, and to give a broader view of what are the implications of the use of energy, and hopefully, yeah, we are actually in the process of including, for example, carbon emissions, because there is a very good data set going back many decades from the Carbon Project, for example, and we want to include that into the data set, and so whatever is complementary to energy, like you said, it's important to demonstrate also to the service. But we also need to bear in mind that there are other sectors, like Carlo presented. There are several other sectors, and there may be some overlap between one and the other. So we need to watch a bit that we don't step over the other sectors too much, but it's important also to make the connections where they exist. And that also relates to forest management, which is a bit outside the scope of C3S Energy. There is a question on the chat, and that is addressed through other sectors in the C3S sectoral information system. So I would invite you to visit the climate page of the C3S, and there you find all the other information. So I would like to thank everybody for the participation, and we're gone a bit over the hour, so it's a good time to now wrap up and remind you that there is going to be another session in less than an hour, and that is about the case studies for C3S Energy, but also several invited speakers. And I hope all of you can join. There'll be other people joining us as well. So we look forward to seeing you at the next session. But thank you very much for participating in this one. And thank you to all the speakers and the team that have contributed so greatly to the C3S Energy Operational System, and to C3S Energy for the support. And thank you also special thank you to Janice for having put this symposium together. She's done a tremendous work to arrange all the logistics, all the program and so on. So thank you, Janice, for this. And thank you very much, everybody, again. And we'll see you in 55 minutes. Goodbye.